Okay, this lecture is over Module 4 of your curriculum. As we can see here, it's titled Inter-VLAN Routing. So why should you take this module? Well, to learn about how to segment and organize your network, specifically using VLANs. As far as what you will learn in this module is we'll talk about what inter-VLAN routing is. We'll talk about something called router on a stick. We'll talk about layer 3 switches. Normally switches are a layer 2 thing. And then we'll talk about how to go about troubleshooting any VLAN routing problems that you might have. So what is inter-VLAN routing? Basically it's routing that's needed for frames to make it from one VLAN to communicate with devices on another VLAN. Just like we would need to route to communicate from one network or LAN to another network or LAN. So these are just virtual LANs, so we still need routing. There are 3 different types of inter-VLAN routing. Each of these will be discussed in upcoming sections, but there's legacy inter-VLAN routing. It's older, as the name legacy implies, and it does not scale very well. We have something called router on a stick, which is for small to medium networks. And then if you have medium to large networks, we use layer 3 switching with something called SVIs, which are stands for switched virtual interface. So the next section talks about legacy VLAN routing. Basically, we connected router interfaces to switch ports for the different VLANs. So we would do that, and we have a VLAN here and a VLAN here. We have connections to our router so that the router could do the routing between the VLANs, because that's what routers are for. Like I said, that was the way it was originally done. That's considered an older method and does not scale very well. Router on a stick, we basically have kind of the same thing. We have sub-interfaces which are assigned to represent interface.VLAN. So you'll see here in our sub-interfaces we have an IP address, and then we have an IP address. It's on a particular VLAN, and then we have interface.VLAN number. So there's an animation down here. Basically we have PC1 right here that's on VLAN 10, and it's going to want to talk to PC3 over here, which is on VLAN 30. And the way that happens is we go to this switch. We have a trunked connection, so we have a tag frame. It goes up to the router. The router then sends it back out the same physical interface, but sub-interface.30 for VLAN 30, and then finally it will make it to PC3. If PC3 is going to reply, we're going to have the reverse of that process. It's going to go up to the router. It's going to come in G000.30. It's going to go out G000.10. Again, the same physical interface, but we have this concept of sub-interfaces where we have kind of a virtual interface, I would say, or call it, for each of the VLANs. And then for bigger networks and newer networks, what we're going to do is we're going to have this switched virtual interfaces. So there are a number of advantages to doing this. The main one is it's much faster than the 2 previous methods that we talked about. We don't have to have external connections to switches for this to happen. because we have a virtual switched interface in the router. It's not limited to one link because we can use Ether channel as trunk lines. We haven't talked about Ether channel, and as you can see over to the left, that's the topic of Chapter 6, but that's basically bonding connections together to give more bandwidth. The latency is much lower. Anytime we pass through a piece of networking equipment, there is latency introduced into the frames. Travel time, fewer devices means lower latency. That's it as far as the advantages. I don't know if they list the disadvantages. Yeah, right here it is. The disadvantages, they're much more expensive. The flow of traffic, however, is very similar to router on a stick. Section 415 is a check your understanding over these topics, the introduction to Inter-VLAN routing. You, of course, can do this on your own. There's 3 different scenarios here, and then you answer the questions for each scenario. So we'll jump over to router on a stick. Again, just to refresh your memory, we talked about this in a previous module. Trunk lines are connections that carry traffic for multiple VLANs. And as we can see here, like we talked about previously, we have sub-interfaces. In this case, the physical interface G001 carries traffic and therefore has a sub-interface for VLAN 10, VLAN 20, and VLAN 30. Okay, so we have steps here as far as configuring your VLANs in the trunks. The first thing you need to do is you need to create and name the VLAN so we have some idea what they are. We need to create a management interface. We need to configure access ports, and we need to configure the trunk ports that are part of this trunk line. So down here at the bottom of this section, we're already on create and name the VLANs. So you can get into the sub-interface configuration mode by saying VLAN space the VLAN number. Then we can say name and give it a name. Then we can switch to a different sub-interface, VLAN 20, give it a name. And then in this case, and often in the curriculum, we use VLAN 99 as the management VLAN. So we are creating and naming this. So if we say VLAN 99, for example, and there's currently no VLAN 99, it is created and then named. We created VLAN 99, but we need to configure it so that we can talk to it. So we can go back into interface VLAN 99. We can give it an IP address and subnet mask. We can bring it up by saying no shutdown. And then we can assign a default gateway to that subnet. As far as the switch ports, we need to go in and set them to access mode and then tell what VLAN they're on and then bring those interfaces up. So in this case, we're configuring on switch 1 interface fast Ethernet 0/6 to be on VLAN 10 as shown in this figure. And then to configure the trunking ports, we need to go to the interface on the switch. We need to say mode trunk so we know it's a trunk line, and we need to bring that interface up. So here FA01 and FA05, they're bringing it up, and as we can see down here, as they are transitioned from a shutdown to an up state. These last two lines here are messages that we're getting from the switch that are talking about changes to the status. Now then, down here we need to do the same thing for switch 2. So we're going in, configuring the VLANs that we want to be on the switch. We're configuring the management interface, which is VLAN 99. We're setting a default gateway, and then 0/18, we're configuring it to be on VLAN 20, and then interface FA 0/1. Since that's a trunk line, we are changing its switch mode to trunk and then bringing it up. As far as the sub interfaces on the router, in this case router 1, we need to go through and configure that. There are several different ways that we do that, or I'm sorry, several different commands we have to issue. So we can go into the interface just like before, except we give a physical interface .VLAN number. As you can see here, it says sub if, so we're configuring a sub interface. We can give it a description. We can change or set the encapsulation mode. We can set the IP address and subnet mask, and we need to do that for VLAN 10, VLAN 20, and VLAN 99. And then down here, the physical interface, we're setting its description that this is a trunk link to S1. So that's configuring this router and the sub interfaces and the trunk line between router 1 down to switch 1. Just like we often do in packet tracers, once we think we have configured our topology, we need to go through and verify that we have completely functioning connectivity. So here we're on a PC, we're getting the IP addresses, and then we are pinging the other machine to make sure that we're seeing connectivity. So we're pinging the different IPs that we have in our topology, and as you can see, we are getting ping requests back. Down here, this is a common thing to happen if you configure your network and you immediately turn around to ping. It may take a while for that interface to come up, and the different devices or different connections to auto-negotiate speed and duplex and that type of thing. So the fact we lost a couple of packets here before we started seeing a ping is no big deal. If that concerns you, you could turn around and issue this ping command again, and then hopefully you would get all 4 responses back if the interface is working correctly. As far as going through and verifying that things are working, we use commands that we have seen previously. We can do a show IP route to make sure we have routing table entries with the correct IPs for the various sub interfaces that we have on the router. So that's one thing we can do. We can do a show IP interface brief to make sure the interfaces are up. We can do a show interfaces on particular interfaces. In this case, we're doing gig 001 sub interface, or VLAN 10, and we're seeing configuration information, and then we're also seeing some statistics or counters related to it as far as how busy it is and what the reliability is. Would be 2 important things that we're seeing there. And then we can say show our trunk interfaces, and it's going to bring up the ports, show which ones are trunking, and show what VLANs are allowed on the various ports. .427 is a packet tracer exercise on configuring router on a stick and then verifying that it works correctly. Relatively short packet tracer. I will be assigning that, so watch for that to appear in Blackboard. Following this, we have a lab by the same name. This is what we would do if we were meeting in person. So I will not be assigning that because we are not meeting in person, and again, it's exactly the same as the packet tracer I just told you I was going to assign. So we can move on to section 4.3, which is Inter-VLAN routing using layer 3 switches. Again, this is for much larger enterprises. We can route from one VLAN to another using multiple switched virtual interfaces. So they behave like switch ports. They're virtual. It allows us to connect a layer 2 switch port to a layer 3 or a routed or router port. So it's going to be similar to a physical interface on a Cisco router. So down here in 432, we have the topology. This is on VLAN 10. This is on VLAN 20. This is a layer 3 switch, so we just have that connection, and the VLAN interface is 10.1 is the gateway, so the router with the switched interfaces would be the gateway, and down here notice that the gateway is 20.1. Which presumably is this interface on the device. To configure this, we have to create the VLANs and give them names like we did before, or it's best to give them names. Then we need to go in and create the SVI interfaces. Then we need to configure the access ports, and then we need to enable routing. So that's shown down here at the bottom of this section. Creating the VLANs and naming the VLANs is exactly the same as before. Creating the SVI interfaces, we go in and we say interface VLAN 10. We can give it a description. We can give an IP address, subnet mask, and bring the interface up. We need to do that for VLAN 10 and VLAN 20, and you'll see that we're giving the IP addresses that we discussed in the topology. Then we need to go into the physical ports and change them to switch port access and assign them to the appropriate VLAN. So that's what we're doing there. And then finally, we need to say IP routing to turn on routing on this device. In 434, we're talking about verifying the layer 3 switch inter-VLAN routing. So again, we go in, we look at the IP configurations, and then we ping from one PC to another to make sure it's working. It would also be best to then go to PC2 and ping back to PC1. You actually can have weird things go on due to misconfiguration where you can ping one way but not another when we're going between two PCs. So even though they don't show it again, you really would want to do that. 435 is talking about routing on layer 3 switches. To advertise routes, we need something called a routed port. So we have to create that. And we want to issue a no switch port on a layer 2 port, which is going to convert it into a layer 3 interface. So if we say no switch port, we're saying this is not a switch port. So it becomes a layer 3 interface. Routers operate at layer 3. Once you have the layer 3 interfaces configured, then you need to give it an IP address. So down here we have a topology where we're using a layer 3 switch. This is going through, this is the topology. Down here it says we're using OSPF. This is one of the routing protocols. It stands for Open Shortest Path First. Typically don't talk a whole lot about routing protocols in the past in Cisco 4, but again, as of December 12, 2019, when they changed the curriculum, there's only Cisco 1, 2, and 3, and most of this, as far as routing protocols like OSPF and some of the other routing protocols, should now be in Cisco 3. Yeah, right here, OSPF routing configuration is covered in another course. So I just talked about that. As far as configuring the routing, here's the 5 steps. They're shown down here in detail as far as what iOS commands. So the first thing we would need to do, step 1, is configure the routed port. So basically we're going to use Gigabit Ethernet or G101. Give it a description. Here we say no switch port, so it becomes a routed port, and then we give it an IP address and a subnet mask, and then we issue the no shutdown command to bring it up. Again, we saw this previously. In global configuration mode on the device, we say IP/routing. That turns routing on. Here, again, OSPF is beyond this class, but what we're doing is we are telling what networks are in what OSPF area, and so we're using OSPF, so we just need to do that to bring it up so it can do routing. To verify the routing, we can show IP route, and it will go through and show what is directly connected and what VLANs we have. And then verifying connectivity is the ping command. Here they actually did show they're on PC1 pinging PC2. Here they're on PC2 pinging PC1. So they're actually making sure they can go through and ping both ways. .438 is an activity on what we just covered here. I am going to be assigning that, so watch for that to appear in Blackboard. Okay, we'll move on to 4.4, which is troubleshooting Inter-VLAN. Here they have some possible issues. This is not necessarily all-inclusive, but it's some of the more common things that may happen. We may not have a VLAN configured. So if we don't have it on a trunk line or on a switch, or we did not configure the VLAN at all, that's going to cause a problem. Over here, they're showing you some of the commands you can use that allow you to figure out if you have a missing VLAN. We may have trunk port issues. So we would want to show our interfaces that are trunk lines, and then we might want to look for the configuration commands to set up those trunks by showing the currently running configuration on the device. Switch port access issues. Maybe we have a routed port set to a switch port or vice versa. That's going to cause us a problem. So we can show interfaces switch port to see which ones are short switch ports. We can look at the running config for the various interfaces to make sure they're configured correctly. And if we're talking about a PC, then we would want to use the IP config command to look at that. If we have router or routing issues, we can show IP interface brief, and we can show interfaces to go through and make sure they're assigned to the correct VLAN and everything is working correctly. So here is a topology that we have. Again, it's router on a stick. We have two PCs connected to different switches. We're supposed to have trunk lines between the router and switch 1, and switch 1 and switch 2, as shown here kind of in this orange color. Here is the VLAN sub-interfaces that we want on router 1. So this is the topology that we're going to talk about. Here, as far as looking for missing VLANs, we can do a show VLAN brief. Here we have VLAN 10 that has one port in it. We have VLAN 20 that doesn't have any ports assigned to it. So if we go through and pretend that VLAN 10 is accidentally deleted, notice that VLAN 10 totally disappeared here. So we would need to go back and add that back in. We can also go through and show an interface, FA6, the switch port commands, and it will go through and tell us how that is configured. Notice that VLAN 10 is currently inactive. So what we would need to do is go back, add VLAN 10, and then we can go through and add the port FA06 into VLAN 10. Now when we do a show VLAN brief, we do see that VLAN 10 is here. We didn't give it a name, so it's going to default to VLAN 0010. We can have switch trunk port issues. Again, this is router on a stick. If we go through and show the trunk lines, what it's going to do is it's going to show us that FA01 on switch 1 is a trunk line. So that's the trunk line over to switch 2. It's going to show us that we have the default VLAN ports allowed. FA01, this port is allowed to carry traffic for VLAN 1, VLAN 10, VLAN 20, and our management VLAN 99. And then we don't talk about spanning tree until over here in Module 5. STP stands for Spanning Tree Protocol. So that's what we'll talk about in the next module that I discuss. Down here we're looking at interface FA05, which is here on switch 1 up to the router. Excuse me. And we're going to see the same thing. It's going to tell us what VLANs are allowed to travel over that trunk port. So we just need to make sure that they're all configured correctly. Here we can go through again. This is switch access port issues. So if we go through and say show FA 0/6 switch port, it's going to go through and say that it's allowing VLAN 1. Here, when we're looking at this, it's basically set up for VLAN 1, but nowhere does it mention VLAN 10, which is what we need for PC 1 down here in VLAN 1. So what we would have to do is go to that switch, go into global configuration mode, go into the sub interface mode for the physical port, in this case FA 0/6, and we're going to have to say switch port access VLAN 10 so that we associate switching for VLAN 10 with that interface on the switch. And then the last thing we talk about in this section is routing configuration issues. If you say show IP interface brief, it's going to show you all the interfaces and show you the IP addresses that are assigned to that. Here we're looking for things on gigabit ports that do 802.10 1Q encapsulation. So it's going to show us the interfaces and the sub interfaces, and we want to make sure that these are actually defined and that the protocol is up and running. So here, subinterface.10 was mistakenly, this is real easy to do and overlook. I didn't notice it right now. You may not have noticed, but it's set to VLAN 100. So somebody fat fingered, put an extra 0 on there. So what we need to do is we would need to go in and configure VLAN 10 for that. So basically we do that, we delete VLAN 100, change it to VLAN 10, go back and show our gig interfaces that are doing 802.1Q encapsulation, and now it says 1, 10, and 20 as it should. So 447 is a check your understanding on troubleshooting Inter-VLAN routing. So you can go through and look at that on your own. And then we have a packet tracer activity 448, also on troubleshooting Inter-VLAN routing. So pretty short packet tracer, but I will be assigning that. So watch for that to appear in Blackboard. And then here we have a lab with the exact same name. Since I'm assigning the packet tracer equivalent of this, we will not be doing this lab, of course. And then that brings us to the module practice and quiz. The practice starts with what they call an Inter-VLAN routing challenge, which kind of pulls all that together. It's not terribly long, maybe not as bad as the name makes it sound, but I will be assigning this, so watch for it to appear in Blackboard. Again, 452 is a lab by the same name. Normally I just say I'm not going to assign this, but you might want to skim it to see what they have you do as far as connecting things together. So I would definitely read that and just not totally ignore it. What did I learn in this module? So the relatively long list. You can read through that, make sure you understand the concepts, and the commands that they talk about. And then, as always, we end with the module quiz, which is over the entire, in this case, module 4. So you can go through that and check your understanding. So that finishes up module 4.